we get our greatest amount of useful computation, that too at a low cost. So that is our commodity hardware, and Hadoop is made it like in such a flexible that they can easily run thousands of machines, that too in a single server, in these commodity hardware. Apart from that, the existing tools which were designed, but they are unable to handle large amounts of data, that is your RDBMS, MySQL, these are your database processing applications. And the main purpose of Apache Hadoop project is to provide shared storage and perform distributed computational work. So that is your Apache Hadoop is. Apart from that, as you can see, it provides us a way to process and analyze that to a large amount of data on these commodity hardware. The process of big data on clusters of commodity hardware. Next is your vibrant open source community. That means there are a lot of people who are working on Hadoop packages, which can you can easily contact with them easily, and on the link given below. As you can see, that is http://hadoop.apache.org, where you can easily contact these people who are presently working on this project. Apart from that, as you can see, many products and tools reside on top of Hadoop. Basically, those tools and those technology which we'll be going to discuss in our further slide, that are some are like your Hive, Pig, HBase, Scoop, Yarn. So these are the various technologies which are work on top of Hadoop. So moving ahead now, I'll be going to discuss about, as you can see, these are the various firms like your IBM, Yahoo, Facebook. They are like the main users of Hadoop. They are fully deal with Hadoop. Why? Because they are having large amount of data. So now let's see the major users of Hadoop, who is they are having the large amount of data, and for that they have to handle some platform is they required. And in case of the RDBMS, it is unable to handle. Why? Because RDBMS, it is mainly focused for your handling of your structured data. Though the firms which you are seeing over there, that is your Facebook, you are having the different types of data they are generating, like your unstructured data, semi-structured data, like your comments, your tweets, whatever the post, whatever the comments, whatever the post, or any of your video files which you upload over there. All these comes under the unstructured data, and it is unable to handle through this RDBMS. Presently, they are able to handle, but that too in a limited portion, not in a huge amount. For this, I'm having a best example for RDBMS has been compared to it is quite similar to your one of the car, like the Maruti car, which has the capacity to hold over approx 6 to 5 people over there. But as compared to train, it can handle more than 5 to 6. That's why. But in case of your car, it is unable to unable to catch up the load as compared to the train. Same goes with your RDBMS, is that they are having a limited portion of capacity in RDBMS. As compared to Hadoop, they are having the n number of capacity, which can easily handle these big data. And apart from these companies, I put to rise one question, that which type of companies do you think will benefit from this implementing big data? Implementing big data on this platform, that is your Hadoop. So Jyoti, Geet, Manasa, Prasanna, Subrito, Sanjay. So I've just put it this question, that which type of companies do you think will benefit from implementing Hadoop? Unstructured data. Having Sanjay, could you kindly rephrase your question, that having unstructured data? What does it mean? That what exactly you are trying to ask me? Okay, that's an answer. For the which type, I'm asking which type of companies do you think will benefit from implementing Hadoop? Which type of companies I'm asking? Based on this slide, I have put one question, that which type of companies do you think that will be benefit from implementing Hadoop? Sanjay, Jyoti. Okay, Deepika has given one answer, that any of the companies companies, any of the company. Yeah, obviously, Deepika, the company will be getting a benefit, but I'm asking which type of companies. Okay, not an issue. The answer to this question is it may not be a large firm necessarily, but it has to have a large amount of data. That's the main answer about this question. As Sanjay has put one question, that any company who have unstructured data. Okay, that's good, Sanjay. Yeah, obviously that is also a good answer. One of the answer. Basically, one of the companies, those companies which they are having a large amount of data. It's not like that, only the unstructured data. There are various types of data too in big data. There are various types of data. It comes under the category of big data. First one is your structured data, like whatever the data. Let me give you a brief description about big data. Like basically a big data, it is a large amount of data which is very complex and has been divided into various data sets that we call as a big data. And inside that big data, there are various types of data. First one is your structured data, second is your unstructured data, and third is your semi-structured data. If we talk about structured data, basically whatever the data which we store in RDBMS, like in the format of tables, like in the form of columns, rows, they are known as big data. They are known as big data, and they are known as structured data. And apart from that, if we talk about unstructured data, whatever you're like, as I've already told you, the comments, the likes, the tweets which you put over there, all these comes under your unstructured data, like your audio files, video files, and your PDF files. And if you talk about semi-structured data, they are like your XML files, your HTML files, SMS file, like your SMS, GPS data. All these comes under your semi-structured data. So that was a short description about big data. So now moving ahead, as I have put the question that which type of companies do you think will benefit from implementing Hadoop? The answer is it may not be a large firm necessarily. Why? Because it has to have a large amount of those companies which are having large amount of data. For them only Hadoop will be going to be a big benefit. If we talk about one example, let's take an example, law firm, like any of the law company, may have a big insights, whatever the data they are having, big insights in a law firm, but it may not have that much amount of data which qualifies it to be a big data. Thus, they won't be needing a Hadoop distribution in law firms. They can work with traditional database processing applications, as you have seen, like your RDBMS, ORDBMS. So that's the reason. The main thing is that any of the companies, they are having a huge amount of data. In that case, only these companies will be going to implement Hadoop. So I guess you are clear with this. Geet, Narangi, Jyoti, Manasa, Sahil, Sarangi, Sanjay, Sarangi, are you cleared with this? Okay, that's perfect. So now moving ahead, as you guys can see, let's have a short description about your Hadoop history. As you can see, in 2002, Doug Cutting, he started with a web crawler, that is Nutch. Are you guys aware with this term, Nutch, a web crawler and all? Geet, Manasa, Mayank, are you guys clear with this? The term, have you ever heard about this term, web crawler? It's nothing like, it is one of the programs. It is one of the programs which was run in Java, and it has a capability that which automatically and systematically indexes web pages on the World Wide Web. And in simple term, I can see that web crawler, it is your open source web search engine. Okay, that's good. That Sanjay is aware with this term. Jyoti, okay. Sahil, okay, that's good. Nilupa was not clear about this term. Okay, not an issue. I guess Nilupa, you have now aware with this term, that what exactly a web crawler is. Nagarjuna, are you cleared with this term, Nagarjuna? Okay, okay, Nagarjuna is cleared. Nilurupa, are you there? Okay, that's good. So now that was a short description about the web crawler. Now, as you can see, in 2003, Google describes the Google file system and published a paper that indicates MapReduce implementation. And in 2004, Doug Cutting adds distributed file system and MapReduce support to Nutch. That's how the starting of Hadoop was there. Okay, that's good. So apart from that, as you can see, in 2006, Cutting joined Yahoo. They described the dedicated file system to turn it into Hadoop. From there, the starting of Hadoop was there since around 2006, and though Cutting started, though why? Because he along with Mike Caffarella, they both joined, and they have created this technology, that is your Hadoop, with the help of the dedicated file system, that is your Google file system, along with the MapReduce, which supported the Nudge. That's how your Hadoop distributed file system came. Along with that, your main technology which works on big data. And as you can see, in 2007, New York Times describes like they converted the 4 terabytes of image archives over 100 EC2s. So are you guys aware with this term EC2? Sanjay, Subrato, Sahil, Mayank, Nilarupa, Geet, are you guys aware with this term EC2? What exactly EC2 is? Okay, that's good. Sanjay is aware with this term. Okay, Sahil is also. Subrato, okay, that's perfect. Mayank is not clear. Shrishti is not clear. Jyoti is not clear. Okay, not an issue. I'll be going to explain you. So basically EC2s, like they are your like Amazon Elastic Compute Cloud, and it is one of the central part of Amazon Cloud Computing Platform, where it it allows users to run virtual computers so that they can easily run their own computer applications. So that's what your EC2s are. And as you can see, in 2008, at the starting, fastest sort of a terabyte, that is in 3.5 minutes, over 910 nodes was done. And in the mid of 2008, Facebook launches Hive. As you guys aware with this term Hive? I don't think so, because some are there, like they are aware with this term, not an issue with that. Basically Hive, which comes under our course, and this technology is very much helpful. And though Hive is like your like in simple way that it supports SQL, whatever the program, I guess you have done your queries in SQL, same case you'll be going to do in Hive also. Apart from that, it makes accessible data more easier because it hides the complexity of your MapReduce. Though I've given a short description about Hive, apart from that, in our further slides also I'll be going to give a short description. Why? Because this technology will be going to learn more detail in our like the end of the sessions, like end of the course. During that time we'll be going to learn. Why? Because I have as guys you have seen in the index page, where we'll be going to have a session, separate session, that too in detail about the Hive also. And finally in 2008 itself, Cloudera was founded. Cloudera, it's an American-based software company and that helps to provide like the Apache Hadoop based software. Apart from that, they support, they give services, and as well as they are giving training to the business customers also. So that's how the Cloudera was founded during that time. And remember, in 2009 itself, Doug Cutting joins Cloudera. Why? Because Cloudera is one of the fastest as well as one of the like major companies who are dealing fully with Hadoop. That's why we have mentioned the name over here. And in 2009 itself, the fastest sort of a terabytes, that is 62 seconds, over 460 nodes were done, and that too sorted up petabytes in 16.25 hours, over 3,658 nodes. That was the fastest sort done during that time. And apart from that, Hadoop Summit, which was held in Santa Clara in 2009, and there were like around 750 attendees has joined this Hadoop. Basically the purpose of Hadoop Summit is to, why? Because they have just gathered together over there and they are sharing the knowledge regarding this big data, that how we can control this big data, what are the like future challenges just coming towards for the big data, and apart from that, which are the technologies which are working on Hadoop. So this is how the Hadoop Summit works. And finally, this was a short description about your Hadoop history. Are you guys clear with this? So now I'll be moving ahead with our next slide. Sanjay, Subrato, Sahil, Mayank, Nilurupa, Nagarjuna, Jyoti, are you guys clear with this? Short description about Hadoop history. And rest I'll be going to discuss in our further slides. So guys, I guess you would be interested to know about the origin of these names like Nutch, Hadoop. The first one is your Nutch. It is a word for meal that his son, that is dough cutting son, used as a toddler. Same goes with Hadoop also. A Hadoop stuffed, it's like a stuffed elephant name by his son. Like a child during their childhood, like they used to say any of the names. No? So that's why how the big dough cutting found this name, Nutch, Hadoop and all. So that was about the names come from. So now moving ahead. Now guys, we are going to learn that how basically our Hadoop differs from relational databases like your MySQL, Oracle, RDBMS. So as you can see, there are 4 points which we'll be going to discuss based on that 4 points. First one, that is your RDBMS, which provides vertical scalability as compared to Hadoop, which provides horizontal scalability. Now what exactly the term is here? That is vertical scalability. It means like that you can scale up by adding more power, such as your CPU or RAM. For example, in your system, if you need like for example to run a game, in that case you need a 8 GB RAM, but presently you are having only 4 GB of RAM. In that case you can easily replace the 4 GB of RAM with 8 GB RAM, but there will be a limit to extend the hardware. But in case of Hadoop, if we talk about horizontal scalability, it fully deals with like adding more number of like n number of machines into your pool of resources. So that's the first and the foremost difference between the vertical scalability and horizontal scalability. That is the existing database processing applications as compared to Hadoop. Now if we talk about our second point, that is RDBMS. As I've already told you that RDBMS fully works on structured data tables, data in the predefined schema, as compared to Hadoop, which is like very much flexible with the structured, unstructured and semi-structured data. So for this, as you can see, the predefined schema, the term predefined schema, it's like it's an already in a structured form, like whatever the tables which we are having in MySQL, that is in the form of rows and columns. That is your predefined schema. Whereas in Hadoop, it is like flexible and it is mainly for the data which is like unstructured, structured, and like some other data like your semi-structured data too. As come to your third point, as you can see, RDBMS, it is best for the online transactions as compared to Hadoop, which is best for the offline transaction. As in this particular point, somehow like somewhat in little portion, Hadoop is in like having a disadvantage based on this one. That is RDBMS, that is for the online transactions, and whereas Hadoop, it is not best for the online transactions. Why? Let's I'll give you one simple example for your online transactions for the RDBMS. Basically, RDBMS, it allows your OLTP, that is online transactions processing application. For this, I'm having a good example. That is your ATM. There are like around 32,000 ATMs in Delhi. So you could imagine that how many number of ATMs are there in all over India. Apart from that, the processing speed of transaction, that is like very fast. Like as soon as you just from the savings, you have just withdraw your money. In that case, automatically within a fraction of seconds, you'll be getting the data that this particular amount has been withdrawn from your account. But same goes with your Hadoop, that is for the offline transactions, where in this case you will be only going to save your data, process and analyze your data. That's it, not apart from that. So that is some more small drawback with the Hadoop, not an issue. But why? Because Hadoop, which we are going to keep, or which we are going to apply in our future also, or presently whatever the companies which are working on that, they are basically mainly for the data, that is for the big data. where they can easily process that data, analyze that data, and with that data it will be helpful for the organizations as well as for any of the individuals too. So that's why Hadoop is very much used in the market. And now the final point, that is our fourth point for the comparison. As we can see, the RDBMS, it doesn't allow large amounts of data. As I've already told you, that the capacity in RDBMS, it's like there is a limit. But if we talk about the Hadoop, there is no limit. It can save large amounts of data. So this is your four main comparisons between your existing architecture as compared to the Hadoop. So I guess you guys are cleared with this. Prasanna, Manasa, are you guys cleared with this? Shrishti, Sanjaya, Nilurupa, Nagarjuna, Sahil. Okay, Sanjaya cleared, Manasa cleared, Jyoti cleared, Geet cleared. Okay, that's good. Okay, Nilurupa. Okay, perfect. Not an issue. Okay, so guys, I'm moving ahead. So as you can see, this is another slide that is fully based on your Hadoop cluster. As you can see, Hadoop cluster, it is designed for storing and analyzing big data in a distributed environment, which means like in a Hadoop cluster, we can easily store the big data and analyze it. We'll see the structure of the clusters in our further slide that I'll be going to show you. Structure of the cluster. Like over here also you can see, just a moment, I'll be going to show you with the highlight. As you can see, this is the portion. This is the cluster of data. As you can see in the slide I've been. Okay, Sanjay has raised one question, that is there any tool which helps online transactions in for big data? Okay, that was a good question. Okay, one more question is there. Okay. Okay, one more question has put by our Sanjay, that I believe OLTP is a key for big data. No, Sanjay, actually OLTP is fully based for your structured data, not for the unstructured or semi-structured data. And as you have put right, that is there any tool which helps online transactions in for big data? Basically, big data here, the term which we are dealing with that too in the platform that is Hadoop. Here we are just mainly deal with like processing and analyzing the data. So that's the main reason which we are using the Hadoop instead of HDMS, RDBMS and all. And if case as you have raised the question that is OLTP is key for big data, no, because OLTP is fully deal with your structured data. Though in Hadoop, they can easily, okay, that makes it handicapped. Yeah, that's why. So I guess you are clear with this, Sanjay? Okay, that's perfect. Okay, okay, that's good. So now moving ahead, as you can see, like over here, this is the photo. As you can see, the figures you shown over here. This is your nodes. Just a moment. This is your nodes. As you can see, these are your nodes. These particular section are your racks, and the collection of racks, it is known as clusters. And as you can see, the number of clusters over here, there are many clusters are over there. So all these collection of clusters are known as your data center. So the collection of all these data nodes which comes under the which like known as a rack. Like they are this nodes. They are the collection of all the data nodes over here. Where that I'll be going to explain you that what exactly data nodes are there. In our further slides, I'll be going to show data nodes, name nodes, and all secondary name node, all that I'll be going to discuss with. It is just a short description about Hadoop cluster. Now, I guess you guys are clear with this. Like, what is your Hadoop cluster, where we are going to save our data? Though apart from that, one more thing I need to tell you all that. Like over here, that was the thing, and that's why whatever the Hadoop cluster as like playing a role over there, as I've already told you that in Hadoop, if you need something extra, like if you need a required for one more server over there, presently you are having 5 servers over there, and if you need some more extra servers over there, you can easily add up that server. That gives you the horizontal scalability. That's the first and the foremost, the main what you can see, the salient features of Hadoop is that it is your horizontal scalability, where due to that we like there is no required of using this supercomputers to analyze the big data. That's why we have, as you can see, this is your figure where we have to our supercomputers. Why? Because with the help of this Hadoop clusters, that too in a commodity hardware, we can easily save our big data. No need of any supercomputers over there. That does not uses supercomputers or extra, but instead uses set of servers in a set of racks in a data center. So this is how your data center looks like. This is your this is your whole clusters. Whereas you can see the cluster has been divided into number of racks. Inside that racks, all your data nodes has been put over there. And inside that data nodes, you are just having your database. All your data, big data has been stored in your data nodes. And how we'll be going to store that I'll be going to show you in our further slides. So that was about your Hadoop cluster. Now, by moving ahead, I'll be going to explain you some of the Hadoop features. There are mainly 3 features are there. First one is accessible, robust, and finally the third one, that is scalable. As I guess you guys are very much aware with this term, the scalable Hadoop, that basically deals with the horizontal scalability, where we can add n number of machines. We have to just add the thing over there. And if we talk about like the existing architecture, that is for the RDBMS, in that case it mainly focuses on it mainly like comes under the vertical scalability, where if we need like some extra data, like if we want to store any more data, in that case we have to replace the thing. Like as I've already told you, if you want to play a game that supports 8 GB of RAM, in that case whatever the presently you are having a RAM that is 4 GB, that you have to replace with 8 GB of RAM. But in case of Hadoop, there is not an issue. If you are having a 4 GB of RAM, if you want to store a data, in that case with the same machine, that is your commodity hardware, in that case you can just add up 4 more or 2 more or your 12 more GB extra. In that case you can just expand it fully. That is the term for the your scalability. And if we talk about accessible, the Hadoop system can be of like any part. It can be in any part of the world, and the Hadoop client from which the user sends the request can be from any machine, and from any part of the world they can easily access the thing. That's the most salient features of your Hadoop, that is accessibility. Second thing, that is the third thing, because I haven't explained your scalable, accessible. Now the third one, that is your robust. Robust is that even if your server fails, the data will still be available in the system. This is achieved through replication factor. Now what is replication factor? That also I'll be going to explain in our further slide while explaining the blocks of data. Now what is replication factor? Basically in replication factor, the number of times the file has been stored over there, it has to be replicated in the Hadoop system. Like the number of times the file is going to be replicated on the Hadoop system, and by default it's 3, or and it's up to you that how many times you'll be going to replicate your data inside your cluster. So what exactly those things are, that I'll be going to explain you more. Presently we are just dealing with Hadoop, so let's move ahead. Have a query on accessibility. Yeah, sure, Sanjay, as you have a query. Yes, you can proceed. Okay, Sanjay has raised one question that as the data are distributed on HDFS, yeah, obviously the cluster will have part of the data. Maybe. No, yeah, exactly. You are correct that the cluster will having a part of data. Why? That I'll be going to explain you that how the whatever the data which you have like would you have to insert in your HDFS, that data first they will be getting divided into different chunks of data. Okay, one more question that so what is the benefit of having accessibility to one cluster? What is the benefit of having accessibility to one cluster? Basically the accessibility presently which they are like shown over here, that is for the replication of data. If in case your server fails, accessibility here, that is like from anywhere you can just easily access your big data, like as they have given the example that Hadoop clusters can be accessed from anywhere and the client can be from any part of the world, and that we can be easily perform in one of the platform, that is Amazon Web Services. But the robustness, it gives you it basically how will give you the robustness, that even if the server fails, as I've already told, that even if your server fails to provide you the data, in that case it will still be available over there in the system. And this is how we achieve, that is through the replication factor. Why? Because as soon as your data entered in HDFS, first it will going to replicate over the clusters whatever your data is there, and by default it is 3. Though you have not attended last lecture that is based on big data, where I have shown the things that how we whatever the data which we insert in HDFS, that first have to be divided into various nodes, and that nodes they has to be distributed among the clusters, and that too we have to with the replication factor, that too by default 3 times it has to be replicated over there inside the clusters, and it's up to you, like by default it is 3 if you have never put the number over there, or we can proceed. Okay, that's good. I guess you are clear with this term, the accessible, the robust and scalable. Rest Prasanna, Subrato, Sahil, Mayank, are you guys clear with this? Okay, that's perfect. Okay, Nilupa, okay. Okay, that's good. Okay, Geet has, okay, that's perfect. So Jyoti has raised one question that how it is, how it can be the term for the robust. Okay, Jyoti, I got your question. That basically you want to need an explanation for the robust and scalable. Okay, basically Jyoti over here, as you can see, the robust, the term over here, it basically deals with the whenever a file that has been put it in like your server, if it fails, that possibly that the thing won't be coming over there, that the server fails. Why? Because we are having already the replication of our data over there. That's why it won't be like giving you the thing that our server fails or you are not having any of the data. Why? Because at the time of like inserting our data in HDFS, during that time we have just replicated our data into the clusters of our data, into the clusters, and that too by by default 3 times we have replicated our data. That's why we won't be getting, that's why it follows one of the philosophy, that is write once and read multiple times. And basically the replication factor which they are doing over there, that is mainly for the durability of a data, scalability of the data, and finally the throughput of a data, so that if server fails, in that case they can easily get the data from different node and they can provide you the data. That is the one of the main and the best features of robust. And if we talk about scalability, as I've already told you, Jyoti, the scalability follows the horizontal scalability. That means if you need a system, presently you are working on like for example 8 GB RAM. In your machine you are working on an 8 GB RAM, and in that case you need a like to run a file or to run that particular data which needs like 16 GB RAM. In that case you can easily put one more, you can just add up one more RAM over there. Are you clear with this, Jyoti? That you can, how we can just add up the number of machines over there. That is your horizontal scalability. That is one of the features of Hadoop. Okay, Jyoti is cleared. That's good. Prasanna is cleared. Okay. So now moving ahead. So as you can see, we have completed some of the portion. So based on that, I'll be going to ask some of the questions, and that it's just a recap, guys. So I guess you are aware with this, the answers of this question. That first, what is a web crawler? What is Google file system? Like the third question is how Hadoop differs from RDBMS, and the fourth one is what is commodity hardware, and finally the last one, that is any two features of Hadoop. So till now, are you guys cleared with these questions? That what is web crawler? Sanjay, Manasa, Prasanna, Jyoti, Shrishti, Deepika, Nilurupa, Nagarjuna. So are you able to answer all these questions? What is web crawler? What is Google file system? How Hadoop differs from RDBMS? And finally, what is commodity hardware and any two features of Hadoop? Okay, that's perfect. So everybody is clear. Okay. Okay, that's good. So I'm moving ahead. So now I'll be going to discuss you guys about the ecosystem of Hadoop. So this is your ecosystem of Hadoop. As you can see from the figure, there are two portions which has been colored with the blue and the rest in green. The two portions, these are the two major components of Hadoop. First one is your HDFS. The other one is your MapReduce framework. MapReduce, which is your data processing framework. First, I'll be going to discuss about HDFS and MapReduce. Then I'll be going to move ahead with the rest of these technologies, because these are the technologies which we're going to work on Hadoop, inside Hadoop. So basically Hadoop, they're having the two major components. Guys, I'm just repeating this term, that is the two major components, that is HDFS and MapReduce. Now HDFS, it is your HDFS means your Hadoop distributed file system, and work is to hold the large amount of data across multiple nodes in a cluster, the main function of the HDFS. Apart from that, it provides high throughput access to application data, and it is also suitable for the applications that have large data sets. In simple term, you can just make a sense from that. The Hadoop is basically for storage. Like whatever the data which we store, that we store in HDFS. That's the main thing. And apart from that, we are having MapReduce. MapReduce is used to analyze the records. Like as I've already told you, that basically Hadoop, inside Hadoop, two functions are there, two major components. What exactly Hadoop do? Whatever our big data or any of our data is there, that data, it first processes the data, it analyzes that data, and it will generate the output. That's what exactly the Hadoop does. And for that, HDFS is there for storing. Like first we have to store that data. Again, that data has to be divided into various blocks. That blocks has to be replicated in our various clusters, which is over there. After getting replicated, they will be performing some of the operations. That is your MapReduce. Inside MapReduce, there are two phases. First phase, which consists of mapping and sorting, and second phase, that is your reduce, which consists of implementation of the logical operations. That is your MapReduce. So this is your HDFS and MapReduce. These are the two major components of Hadoop. So guys, just be aware with this term, HDFS and MapReduce. And let's come to the other sections of our Hadoop ecosystem. Let's talk about first, that is a PIC. PIC, it is used for analytical large data sets. I'm just giving a short brief description about these terms, so that you'll be able to aware that what exactly Hive is, PIG is, HBase, Zookeeper is. And next, for the HDFS and MapReduce, that I'll be going to discuss in our further slides in this session itself. and rest I'll be giving a short description so that you'll be just able to aware. Otherwise, these all are the single topics which will be having the day sessions in a further sessions itself. So now let's talk about PIC. It is used for analysis data sets, large analysis like large data sets, and PIC mainly focuses on like what is to be done on that data rather than how it is to be done. And it is the reason that why it gets slow for small sets of data. That's why PIC like obviously it is very slow for the small data sets, and if we talk about large data sets, that means it is very fast. That's how. And the advantage of PIC is that it can handle any type of data like your structured, unstructured, and your semi-structured data. So that's what a small description about PIC. Let's talk about our Hive. Hive basically supports SQL. As you can see, as you are very much aware, the whatever the queries which you have done in your SQL, same case you will be going to perform in a Hive. That's it. Hive supports SQL and it makes accessible data easier because it hides the complexity of map-reduced jobs. Example, it only deals with the structured data. Why? Because as in Hadoop, as I've already told, that it will be going to handle all types of data. There's unstructured, structured, and semi-structured. So for the structured part, Hive will be going to handle all these data. And if we talk about HBase, it is a column-oriented database management system which is running on top of HDFS. And HBase, it does not support SQL, that is your structured query language. It mainly supports NoSQL, that is not only SQL. What is that? That will be going to explain in our further slides too. And finally come to the Zookeeper, that is basically it is a cross-cluster service and it relies on like centralized infrastructure. And in simple terms I can say that Zookeeper is your coordinating service with Hadoop database, that is your HBase. Presently the Facebook they are using Hadoop database where they are dealing with the data, all stores of data. So that is the thing. So this is your ecosystem. Now I guess you guys are aware with this ecosystem of Hadoop, and the main core components are your MapReduce and HDFS. So Shrishti, Deepika, Jyoti, Geet, Manasa, Sahil, Mayank, I cleared with this. Sanjaya, I cleared with this, the ecosystem. Okay, Jyoti cleared, Mayank, okay, Sanjaya, okay, that's good. Nagarjuna, perfect, okay, that's good. So now guys, I'm moving ahead. As you can see, this is the thing which I have already repeating from since our previous slide, that is the Hadoop has two main systems. These are the two main core components. First one is your Hadoop distributed file system, the other one is your MapReduce. As I've already discussed with you all, that Hadoop distributed file system, it is one of the distributed file system which holds the large amount of data across multiple nodes in a cluster. And same goes with your MapReduce. It is a distributed programming paradigm, and under this like the two phases are there, that is one is map phase, the other one is reduce phase, where first phase will be going to deal with mapping and sorting, and the second phase, that is your reduce, where your data will get reduced. The reduce term here, it's not like that your data of 1 GB will get reduced to 0.5 GB. It's not like that. Here the term for reduce and mapping basically for the whatever the data which you insert in HDFS or in Hadoop, that you'll be getting first, it will get processed, and after getting processed it will have to be analyzed. That analyzed data you'll be getting in HDFS again. So that's how the help of that data you can easily it will be like helpful for any of the applications, like in any of the various big firms or to any particular individuals. They can easily rectify or analyze with the help of that big data. So this is how your HDFS ecosystem till now works. Now I'll be going to discuss about, as you can see, these are your tools. So these are the tools which I've already told you. Some are like, why? Because these tools will be going to work on your Hadoop platform with the help of HDFS and MapReduce. then only it will be formed as a Hadoop ecosystem, in which there are many technologies. First, that is your Hadoop database, that is your Apache Edge base. As I've already told, that it is a column oriented database built on the top of HDFS, which I've already discussed in that previous slide. As you can see, the scoop, this is a new term. As this also you'll be having a separate session for scoop, for HBase, Hive, Pig, Zookeeper. All these you'll be having a separate session, whole session. We'll be going to discuss more deeper on these sessions itself. If we can say, as you can see, Hive, as I've already told you, that Hive, it is a data warehouse with SQL interface where you will need your like your commands and like queries, that how you have performed in SQL queries. Same case with the Hive also. We talk about the Pig, it is like your data processing language and it helps in execution. And HBase, as I've already told you, that it fully deals with your structured, whatever the structured data in Hadoop is, that deals with your Hadoop. That is Hadoop database. And now Scoop is your like your data export import tool. It is mainly used for the RDBMS and Hadoop ecosystem. Like whatever the data, it is working as a tool to mainly to export and import between the RDBMS and some of your Hadoop ecosystem. So it is a tool designed for efficiently transferring bulk of data from your RDBMS to HDFS. That is your Scoop. And finally a Zookeeper, as you have seen in the corner, that is high availability coordination service. Basically it provides the coordination among all these technologies with the Hadoop platform. That is under which the two major components are the HDFS and your MapReduce. Mainly it helps in coordinating the service. So this is all about your Hadoop tools. Apart from that, presently I'm just give a short description regarding these tools. Later on we'll be having a separate session for Hive, for HBase, for Pig. During that time we'll be going to study more deeply. So this is the thing. So now I'll be going to discuss about the Hadoop distributions. So guys, this is your Hadoop distributions over there. As you can see, these are your various big firms which are going to deal with that. While you may be thinking that why Hadoop distributions is necessary when there is already an open source Hadoop. You guys don't be like confused with the Hadoop distributions and the Apache main Hadoop. It's like quite similar like your Linux. Like presently whatever the Linux code which you can easily edit, and finally you can just frame it to your new distribution. Some of your Linux distributions like your SUSE, your Red Hat, Mint, all are here comes under the Linux distribution. Same goes with your Hadoop distributions too. While like Hadoop distributions like mainly aim to resolve version compatibilities. As some are like mentioned over here, that is your cloud era distribution for Hadoop that we call as CDH, that is the cloud era. As I've already aware with this term, I guess, cloud era. That's one of the American software based company which is fully based on, fully dealing with Hadoop to handle this big data. And if we talk about Green Plum, like HD Data Computing Appliance, they are having their own distribution of Hadoop. Same case with Mappa Technologies, Apache top distribution. Finally, the Hortonworks data platform. So these are the things which is shown over here. As you can see from this, one question is arise that why Hadoop distribution is necessary when there is already an open source Hadoop. I've asked this question, why we need as many number of distributions, though we are already having an Apache Hadoop distribution. So guys, are you having the answer about this? Prasanna, Manasa, Geet, Sanjaya, Sahil, Mayank, Nilarupa, that while you are like you are already having an Apache Hadoop, but still you need some, like there is a necessary, you're already having an open source Hadoop. Why is it so? Okay, not an issue. I'm having this answer. So the answer is that, like whatever the open source softwares, like they tend to have anomalies and cannot be implemented in real world situation. Like apart from this, there are many more cloud error, like your Hadoop distributions are also there for like different firms. For example, you're having for this IBM, that is your big insights, InfoSphere big insights. So that is the distribution, Hadoop distribution of IBM. So some are like dealing with real world and some are like cannot be dealing with the real world situation. Like if we talk about in a banking firm or in research for research work, the Hadoop platform won't be workable in banking firm as well as in research firm. And as you can see, all these companies, they provide Hadoop distributions which can be implemented in the real life scenario also. So these are the Hadoop distributions which can be implemented in your real life scenario as compared to the some other section, that is a banking firm and in research firm. No need of your real world, no need of your Hadoop distributions in your real world situation, that is in banking firm and in research firm. And these companies also provide support on their distributions too. That's the main benefit. Like after having their own distributions, apart from that also they are just providing the support systems to their distributions. Then only they will be able to perform the real life scenarios. But in case of some of the distributions, like some of the anomalies, they cannot provide you the real world situation. So that's how the Hadoop distributions aim to resolve version incompatibilities. There are many more companies, they're having their own distributions of Hadoop, as you can see over here. For the Hortonworks, MapR Technologies, they're having MapR distribution, MapR 18, MapR 17, MapR 15. So MapR Sandbox. So these are the various distributions of Hadoop. So that's all about your Hadoop distributions. So more that we'll be going to learn in our further slide. As you can see, these are the supported operating systems. Some of the software operating system, apart from there are many more. Some are like your SUSE, Ubuntu, CentOS, Red Hat, and Oracle. Guys, I'm having one question based on this slide. That as you can see, these are the supported operating systems for Hadoop. Now can you tell me one thing common among all these operating systems? Can you tell me one thing common about these operating systems? Okay, that's perfect. Sanjay has answered me. Okay, Jyotis has also answered me. Shrishti, okay, that's good. What about Nilurupa, Nagarjuna, Sahil, Subrato? Are you guys? Okay, no. Okay, Sahil, no. Okay, not an issue. Okay, Manasan, no. Okay, that's good. Subrato, okay. Yes, okay. Yes, Sanjay is right. Jyoti is right over there. Deepika is right. Okay, that's good. Yeah, basically, apart from Red Hat is your Unix operating system as compared to all. They are based on Linux-based operating system. So that is the common thing about that. But there is not an issue that this is from Unix and this is from Linux. It's not like that. They all comes under the same category. They are right operating. They are like your Linux-based operating system. So that's all about till this slide. Now, as you can see, we will be going to further more deeper in Hadoop. Now, guys, we will be going to see that the various cluster modes over here. As you can see, this is your 3 types of cluster modes. Out of this, 3 you have to configure. Out of this 3, like any one you have to configure to run your Hadoop cluster. So as you can see, first one, that is your standalone or local mode. Second is your pseudo distributed mode, and finally the third one, that is your fully distributed mode. So this is your cluster modes where you'll be going to configure in your operating system. With the help of that only, you'll be going to run Hadoop in your system. So first, let's talk about this standalone or local mode operating. That is your cluster mode. If you talk about standalone mode, like only MapReduce program can be executed under this. Are you getting my point? That in standalone mode, that is your local mode. In local mode, only MapReduce program can be executed. Here, like whatever the input file which you'll be taking, you have to take it from the local file system itself, and apart from that, you have to put it instead from HDFS. Instead of from HDFS, you have to take your input file from local file system, and apart from that, whatever the output it will generate, that will be stored in your local file system itself. There is no HDFS in this case. It is same as your Java program. So that is the thing about your local mode, that in local mode, whatever the file which you are taking, input file, that you have to take from your file system, local file system itself, and after getting the output, after getting the data processed and like analyzed, that data you will be getting in your system itself, that is your local file system, and there is no use of HDFS in this case, only the MapReduce. Why? Because when I have to perform the MapReduce, why? The main portion of that, it is the two major components of Hadoop is your HDFS, which deals with your storing of data, and if we talk about MapReduce, it has to perform the two operations, that is the mapping function and the reducing function. But in this case, standalone, that is a local mode. Inside this, MapReduce perform will be there obviously, because it has to process the data, analyze the data, and based on that it will give the output. But the main thing is that it won't be using the HDFS. There are no use of HDFS in this case. It will be same as it is your Java program. Now we'll discuss about the pseudo distributed mode, that is the second type of cluster mode. In this case, all the daemons which runs on the same machine, for example your name node, secondary name node, data node, job tracker, task tracker. Guys, don't be confused about these terms. That is your name node, secondary name node, like your data node, job tracker, task tracker. All these will be going to discuss within a few minutes. In our further slides, I'll be going to discuss about all this, that what exactly these terms are. That is your name node, secondary name node, data node, and what's their main role in Hadoop. And if we talk about daemon, daemon is a process or a software, any of the threads which computes operation. So that is the thing. And if we talk about like simply that pseudo distributed mode, it mainly used for the development and testing purposes, and somehow it looks like your fully distributed mode too. So this is your pseudo distributed mode. So finally come to the third cluster mode, that is your fully distributed mode. In this mode, all the daemons which I have already discussed, that is the name of the daemon is your name node, secondary name node. Just be focused with these names, because soon in our further slides I'll be going to discuss about these names based on these names. That is why, because it is the main value, they are like playing a major role in this main Hadoop. That is your name node, secondary name node, data node, job tracker, task tracker. So all these are your daemons, and they are playing a vital role under Hadoop. So presently I've just given a short description about this. Now further slides I'll be going to explain that what exactly they are. So where were we? Yeah, we are in fully distributed mode. Yeah, in this mode, what are the daemons which I have mentioned just now, which runs on different machine or any of the servers rather than single machine, as we have seen in pseudo distributed mode. Whatever the daemons which I have already told you, that is your single, that is your secondary name node, your data node, all this will run on different machines or servers, different machines and different servers, rather than on one single machine, as we have seen in our pseudo distributed mode. Thus it is used in the production environment. As pseudo distributed mode, they are like mainly for the development and testing purposes. And if we talk about the like your fully distributed mode, they are like in the production environment. They're fully used in a production environment. So that's all about your cluster modes. I guess you guys are aware with this now. Standalone mode, local mode, where we'll be getting the data from our local system itself, and we'll be going to perform operation with the help of MapReduce. No need of HDFS. And if we talk about pseudo distributed file, that you'll be going to perform in a single machine itself with the help of the daemons and it is mainly used in the development and testing purposes. And if we talk about the fully distributed mode, it is mainly works in the production environment where our machine, where whatever the daemons which you're having, that is single node, name node, sorry, data node, your secondary name node, all these will be going to be like run on different machines or different servers. So these are your cluster modes of Hadoop. So are you guys clear with this? Manasa, Geet, Shrishti, Deepika, Sahil, Sanjay, are you guys cleared with this? Nagarjuna, are you guys cleared with this? The cluster modes? Okay, that's perfect. Okay, yes. Okay, yes. Yuti, yes. Sanjay, yes. Okay, that's good. Subrata, yes. Okay, that's perfect. So now guys, I'm moving ahead. As you can see, I have already told you that some of the things which I'll be to mention, which I'll be going to discuss over here, that is your name node, job tracker, data node, and the task tracker. So this is the thing. So this is your Hadoop cluster architecture, which I'll be going to discuss over here. As you can see, as you can see from the figure, that this is your Hadoop cluster architecture, which is also known as, like as you can see from the two sections are there. That is, one is your master slave architecture. It is also known as a master slave architecture. In the middle section, as you can see, this is your master node. There are two components. One is your name node and the other one is your job tracker. That comes under your master node. And if you talk about like your slave node, there are also two components. One is your data node and the other one is your task tracker. Now let's see how these components work inside the Hadoop cluster. So let's talk about first, that is your name node. Name node basically fully deals with your HDFS. Inside this, as you can see, the top portion with the red block, that is your Hadoop client. It mainly contacts with name node for data and or like job tracker to submit jobs. So as you can see from the figure, the name node, that is for the HDFS. What it's like a purpose, and what it's for there, what's the use of it there in master node? It keeps in memory the metadata. Metadata means the data of data. That means the data, all the data, like data about your data nodes, your blocks, which has been stored over there in data nodes. All these information have to be like you have to keep over there in name node. It keeps in memory the metadata about the file system, such as which data nodes manage the blocks for each file. So as you can see, the number of data nodes are there. The n number of data nodes will be there. Same goes with the task tracker. It will be like n number of task trackers will be there. So your job tracker and your name node, which comes under the master node, that will be remain as it is single. That will be your one. Let's talk about your job tracker. It basically coordinates the activities across the slave task tracker. As you can see inside the slave, your task tracker processes is there. It coordinates the activities across the slave task trackers processes, and main thing is that it accepts the map reduce request from the client, and schedule a map and reduce task on that task tracker to perform the task. That's what the task tracker, it's what the job of a job tracker is. That to schedule a job. Schedule a job. What kind of a job? Map job and reducing. Mapping and reducing. These are the two tasks that they have to perform inside the task tracker. That's what the job tracker does. And if we talk about our data nodes, mainly the main nodes, these are the data nodes which communicates with each other for the pipeline of file reads and writes. Why? Because there are n number of data nodes are there. And if we talk about the files which are made up of blocks inside that data nodes, and each file, as I've already told you, as I've mentioned the term, that is the replication factor. That replication factor is like the number of files which are replicated in your clusters. Like whatever the files made up of blocks, and each file can be replicated multiple times, meaning there are many identical copies of each block for the file, and by default that is 3. By default that is B3. That's the work of our data node, or in short you can just say that it stores and serves blocks of data. That's the task of data. That's the work of your which comes under the slave node, under which the data node is the task tracker. So I guess you guys are very much aware with this term and their task too. So Sanjaya, Nilurupa, Nagarjuna, Sahil, Shrishti, Deepika, Jyoti, Geet, are you clear? Are you aware with this term? The data node, job tracker, name node, task tracker. Okay, that's perfect. That's good that you guys are clear with this. Sanjay, okay, that's perfect. Sahil cleared. Mayank, yes, okay, that's good. Prasanna, okay, that's good. Nagarjuna, okay, I understood. Okay, that's good. Okay, okay, that's best. Okay. So guys, I'm moving ahead. As you can see now, I'll be going to explain you more detail. Though I guess you are aware with this term, that is Hadoop core components. First is your HDFS. As I've already told you that it is your distributed file system that provides high throughput access to data. HDFS, it creates like multiple replicas of each data block, which I've already told you, and why they are making that is for the durability, scalability, and for the throughput of a data. That's why replication has to be done over there. So I guess you have seen the slide. I guess you are very much aware of these terms. That is the main core components, the main components of HDFS that are your. Okay, Sanjay has asked one question that name node is stored in flash memory, right? Or flash memory name node, RAM. Uh, Basically, name node is stored. Yeah, obviously name node will be stored in your HDFS. Or is it a database? No, no, no. Name node is not your database. It is basically a master node which has the like a power to handle all the data nodes. And finally, whatever the data which we are having, that we have to store in our data nodes. Where is it stored? Where is it stored? Basically, it's stored in HDFS. HDFS. It's a distributed file system that has to be distributed in different clusters, as I've shown you that first it's a node over there. Inside that node they are like kept it in a racks, and finally the number of racks we called as cluster, and finally the number of like collection of clusters we called as a data center where we store our data. Okay, that's perfect. You are cleared with this, Sanjay. Okay, so this is the main components of HDFS. That is first I have already explained you. That is the name node. As you can see, this is your HDFS cluster. HDFS cluster. Inside that is your name node, and finally the data nodes are there. Where name node having all the details about the data node and the details of blocks itself, where the blocks, that which particular block has been stored in which data nodes. In that case, whenever a client is asking for a data to read and write files, that is the purpose of that is the work of a client, that to read and write files. In that case, first it will going to contact with the name node, and that name node will be going to reply back to the client. During that time, client can easily check out that which particular data is having the which blocks. During that time, they can easily access their data, read or write files. That's how the process works. So now, as you can see, the new term is over here. That is your secondary name node, which I haven't showed you in the figure. That is your secondary name node. Guys, don't be aware, like don't be panic with this. Basically, same secondary name node. It will be like stored inside your master node itself. Near to your name node, like this, and here this is your secondary name node. This is your secondary name node, and basically what secondary name node, like the task of a secondary name node, mainly during the time of like file movements, like the file sharing, or any of the like client is asking for the number of files, then where to read, where to write. During that case, unfortunately, it's not like during that time it happens. If it happens also, like if a name node fails, during that time secondary name node gives the support to name node, so that they can easily, so that the client can easily access the things, that is the metadata, and during that it can easily continue its process with the writing and reading files from the data node. That's what the task of a secondary name node is. That is, it is, or as you can see over here, that it is responsible for performing periodic checkpoints. Periodic checkpoints in the event of name node failure. You can restart the name node using the checkpoints. In that case, name node will be easily accessible to the client. So that's how your Hadoop core components works. And now this is your second slide. That is for the Hadoop core component. That is for the map reduce. So as you can see, this is your map reduce. This is your map reduce engine. It will be mainly dealing with your job tracker and your task tracker. As I've already told you, the purpose of a task tracker, what it is, and job tracker, like it basically, first map reduce client will try to communicate with job tracker. It will like what it will do, it will like schedule the job. What is that job? That job is your mapping and reducing the data. That's what the job tracker basically coordinates the activities across these slave task tracker processes, and it obviously it will accept the map reduce job request from clients, and based on that it will going to schedule the map and reduce task on task tracker, and finally it will perform the task. And finally, after performing the task, again it will be going to store in where it will going to store the data. Again it will be going to store the data in HDFS, from where the data has been divided. So this is the thing, this is the process, how thing works. I guess you guys are very much aware with these terms: task tracker, job tracker, your data nodes, name nodes. Are you aware with this term now? Is that clear with you all? Prasanna, Manasa, Geet, Jyoti, Shrishti, Nagarjuna, Sanjaya. Okay, that's good. I'm getting a positive response that from everybody. That's good that you guys are very much aware with this term now. Sorry for the highlights over there, which I have been forgot to erase. So let's have a recap that what we have learned till now from the previous slides. Now can we say that your secondary name node is housekeeping? Is that Sanjaya, Nilarupa, Mayank, Sahil, Shubhrato, Geet? Okay, Geet. Okay, Geet. Yes. Okay, that's good. Okay, what about Jyoti, Shrishti, Sanjaya? Can we say that secondary name node is a housekeeping? Okay, that's good. Sanjay has answered me yes. Jyoti yes. Shrishti yes. Okay. So can you answer me why? Why we are calling secondary name node as housekeeping? Can you explain me in short? Jyoti yes. Okay. Yeah, that's good. Nilurupa yes. He answered me. Okay, that's good. What about Mayank? What about Sanjay? Okay, what about Shrishti, Deepika? Fast guys, because we are having other questions are also there. It keeps on checking the name node. Okay, that's good. Sanjay has answered me the correct answer. And it keeps on checking the name node. That's perfectly good answer. Yeah, same with the Jyoti also. Shrishti, yeah, that's good. Yeah, that's the other term that is Nilarupa has given me, that its secondary name node is a caretaker. Okay, that's good. Yeah, obviously it's a caretaker of secondary name node. Whenever the name node like it fails during that time, it can easily handle him so that the process continues. So that's the good thing. Okay, our next question, that where do we save the data, in name node or data node, guys? Okay, Sanjay has, okay, that's perfect. Sanjay has given me the correct answer. First attendee who has given me the right answer, that is Data node Sanjay, okay, that's good. Jyoti also, okay, that's good. Okay, Nilarupa, okay, data node, yes, that's good. Sahil, yes, okay, it's a data node. Yeah, obviously it's a data node. That's good. Now, third question, that who performs the map reduce task? Okay, Sanjay has given me the right answer, that is task tracker. Yes, along with him, Jyoti has also given me the right answer. Okay, that's perfect. Mayank has, okay, that's good. Deepika has also given me, okay, that means you guys are very much clear about these terms. Okay, that's perfect. So now the last question, that is who performs the scheduling of the submitted jobs? Job tracker. Okay, that's good. Sanjay has given me the right answer. I'm waiting for the other guys. Guys, where are you? Fast. I need fast answer. Okay, Geet has answered me right. Okay, that's good. Sahil, okay, perfect. Subroto, perfect, that's good. Shushti, Deepika, okay, that's good. Okay, that's best. Okay, so Deepika has also given me the right answer. Okay, what about Sahil? What about Nagarjuna? Where are you? Are you there still over there? Okay, you are there. Yes, okay, that's good that you are there. So what's the answer? Who performs the scheduling of the submitted jobs? Okay, it's a job tracker. Okay, that's good. So guys, you have enjoyed a lot about this session. Okay, that's good. That's perfect. So I guess you guys are very much aware with this term. So now this is your assignment, guys. That is, try out with your Unix commands. That is like it's been over in our LMS that you have to try out, that you have to learn that what exactly some of the Unix commands that you have to have some knowledge. Why? Because it will make you more perfect and it will make you more easier to handle the Hadoop ecosystems. Why? Because while configuring your files, while making your name node, secondary name node, your data nodes, all these during the, like in your Unix, you have to configure each and every files over there. For that, you need to know your Unix. So for that, you have to try out your Unix commands. So which is present in your learning management system, that is your LMS. You can easily have a try over there. So that I'll be going to show you that where you'll be getting your section that is for that. Just a moment for that. Okay guys, so are you all over there? Okay, that's perfect. So now I'll be going to show you. Now I'll be going to show you from where you'll be. You have to access your LMS, that is your learning management system. From where you'll be have to deal with so that you can try out your Unix commands over there. Each and everything perfectly has been shown over here. The main thing is that you have to practice it over here. So first you have to come over here. That is, first you have to log in your account. I guess everybody is there with their login account. Already they have logged in over there. Is that so? Jyoti, Geet, Manasa, Prasanna, Shrishti, Sanjay, Mayank, Nilurupa, Nagarjuna, Shubhrato. You guys have logged in your system with your account? Please give me a quick response. Okay, Sanjay, Geet, okay, Jyoti, that's perfect. Shrishti, okay, Deepika, wait for 2 minutes. Okay, Deepika, we are over here obviously. Sahil, okay, perfectly done. Okay, Sanjay, it's logging in. Okay, that's good. Okay, guys. So what after getting logged in, you have to come to the portion that is your My Courses over there, where you have to click Hadoop. As you can see, it's taking time after getting. Uh, yeah, this is the portion where you have to come over here. So this is the thing. This is your chapter which we have completed today. That is your introduction to big data and Hadoop. Though we have completed yesterday, that is for the big data. Now we have completed with our section that is big data and Hadoop fully. And in this chapter we have explained what is big data, how it generates, how Hadoop works on big data. Now just click on this section. As you can see, this is your portion, and here as you can see the installation of Hadoop in Windows. First you have to learn this one, and this you'll be getting each and every details from a learning management system where each and every steps has been shown over there. For that you have to just click on this section. As you can see the view over there, that is installation of Hadoop in Windows. Just click on that. After getting click, you'll be getting a portion like this. You have to download it. After getting downloaded, you will be getting around this. So this is your thing. So you have to just follow the steps to install Hadoop in your Windows. And after that you have to go for this. Unix is also will be installed in your system based on this by following the steps over there. Guys, just follow the steps precisely, as you'll be getting each and every information regarding this. And finally you have to learn some more more about the Linux commands, because that is the main thing where you'll be going to perform each and every operations on like things over there in Linux itself, as we have performed. As you can see, these are your commands which you have to execute it. These are the command is used to list the files. So each and everything you have to follow this like this. So these are your basic Linux commands. So guys, are you having any queries regarding all these things? Sanjaya, Jyoti, Sahil, Mayank, Nilarupa, Nagarjuna, Deepika, Shrishti. Okay, Jyoti, no problem. Okay, that's good. Manasa, no problem. Okay, perfect. Prasanna, cleared. Okay, that's good. I'm happy with that. Nagarjuna, cleared. Okay. Sanjaya, Sahil, Shubhruto. Okay, that's perfect. Not an issue. So if you are like having any problem regarding that, you can just contact to our support team. So they'll guide you each and everything about how to operate your LMS, that is your learning management system, where you'll be getting each and every materials regarding big data and Hadoop. So good night guys, have fun. And what are the things which I've taught you now, you have to just be focused on that, then only you'll be getting more about. Because why? Because all these things that you have to get more detail in our further sessions too. So thank you guys, have fun. Good night and take care. That you'll be getting the map reduce. Apart from that, we have just displayed the syllabus over there in LMS. Okay, that's good. Okay, bye. Okay, that's perfect. So basically we'll be going to deal with tomorrow, that is your map reduce. Okay guys, have fun. Okay, Jyoti, Deepika, okay, that's perfect. Okay, that's good. Okay, Sahil, okay, that's perfect. Okay, thank you. Okay, good night guys. Take care, have fun.